everybody. I got a few requests to make an answer key video for the homework from Wednesday. So I'm going to just cut and paste the problems that came up on my screen here and walk you through how to do them. Realize that positive physics changes numbers randomly for everybody, so nobody has exactly the same problems. But the general setup for them is all going to be the same, so if you follow my solution, then you'll be able to apply it to whatever numbers come up on your screen. So the first one here I got is a circuit that has A, B, and C. It says, when calculating the equivalent resistance, which just means total, which two resistors should be combined first? I would do A and B, and you can just add them together. And they're in series. So those two resistors would be 70 ohms, 30 plus 40, and the equivalent resistance of all three resistors. I then have 70 ohms parallel to 10 ohms. So to add parallel resistors, you do 1 over each, and together they equal 1 over their total. So 1/10 plus 170 equals 0.114. Just take the inverse of that. You get 8.75 ohms. Next one, which two resistors should be combined? That would be the parallel A and C. And they're parallel to each other. And so these two resistors, you do 1 over 20 plus 1 over 50 equals 1 over the total of those two. Gives me an R total of 14.3 ohms. And all three resistors then, you now have A and C that you've combined to essentially to create one resistor. And it has a resistance of 14.3, and it's now in series with B, so you add the 50 to get 64.3 ohms. Next up is the third question from challenge problems 1. We want the equivalent resistance of these three. Since all three are parallel to each other, we can just do 1 over 30 plus 1 over 10 plus 1 over 50 gives you 1 over the total of the three of them combined. The reason they're parallel to each other is that you can make a path past each one without touching the others. So that would be path A, this would be path B, and this would be path C. They all bypass each other, so that means they're parallel to each other. So if I do 1/30 plus 1/10 plus 1/50, I take the inverse of that. I get 6.52 ohms. Next up is the first problem from challenge problems 2 that I got. It gives us a circuit that has 3 resistors and wants us to fill in this table. So first of all, let's get the units right. Resistance is measured in ohms, current is measured in amps, voltage is measured in volts, power is measured in watts. Next up, I'm going to use what we learned about combining resistors to combine A, B, and C. So A and B together, 1 over 40 plus 1 over 20, take the inverse of that, and their resistance would be 13.33 ohms. And that's now in series with C. So add 13.33 to 20 and you get 33.33 for your total resistance. Our other resistors I can fill in from just looking at the picture. We have 40 ohms for A, 20 ohms for B, 20 ohms for C, and our source voltage is 9. So 9 goes there. Next, we know that V equals I times R. So I put a little equal sign, a little times sign there, so you can see R equals I. R times I equals V. So if I do 9 divided by 33.3, 8.27 amps of current. Now, in terms of current, I'll draw that with like a Sharpie here. Current starts out at the battery, goes along, and then it's going to split. Some current is going to go the outside loop. Some current is going to go the inside route. This all comes back together. To get back to the battery. Now the total amount of current we just figured out is 0.27 amps. when it comes back together, down in front of resistor C, it has to come back to being 0.27 amps. Okay? That way, that tells us that the current at C has to be equal to the total amount of current. So 0.27 amps goes down there. I can do R times I to get V, so 20 times 0.27 gives me 5.4 volts. Next up, any lap, I'm going to erase some stuff here so I can redraw the colored things. Any lap that you make in a circuit, any complete lap, has to add up to the voltage of the battery. So let's say that I went this inside route. That would mean that resistors A and C together have to add up to 9 volts. Well, C is already 5.4, I can just subtract that from 9 to get the voltage across resistor A. So 9 minus 5.4 is 3.6 volts for A. I can do 3.6 divided by 40 to get the current through A is 0.09 amps. And then just like we did with the inside loop, I can do the outside loop. And I know that B and C together have to add up to 9 volts. And again, if C is 5.4, that means B has to be together at 3.6. 3.6 divided by 20 is 0.18. And you can see that the two currents that split to go through A and B together, 0.09 and 0.18, add up to the total of 0.27. To get your power column, that's the easiest one. You can just do I times V for all of them. And it should add up to the source. Alright, here's my second problem from challenge problems 2. Same idea, I'm going to list my given information. 15 volts is the source voltage. A is 30 ohms. B is 30 ohms. C is 20 ohms. D is 20 ohms. I'm going to try and combine all my resistors. So B and C are easy to combine together. They're just in series, so that'd be 50 ohms. That 50 is now parallel to 20, so 1 over 50 plus 1 over 20 gives you 1 over the combination of D and BC. So to do that, I take the inverse of 1/50th plus 20th, which is 14.28 ohms. And then that 14.28 is now in series, last one, but not least, with resistor A, so you can just add them together to get 44.28 for the total resistance. I can use Ohm's law, R times I gives you V, so 15 divided by 44.28 gives you 0.34 for a total current. So just think that, I got 0.34 amps of total current. That same amount of current has to go through resistor A because it's right next to the battery and the current hasn't split anywhere yet. So 0.34 goes through A. I can do 30 times 0.34. To get the voltage drop at A, it's 10.16. Then I'm going to use my voltage rule that any lap you make has to add up to the battery. So if I went, let's say, the outside route, that has to add up to 15 volts. So if I've already dropped 10.16 at A, that means the other, 4.84 volts has to be at D. So then I can use Ohm's law, 4.84 divided by 20 is 0.242 amps of current. And then I'm going to use my voltage rule again. If I want the inside lap, that means I went through A and used up 10.16 volts. The other 4.84 volts are going to be used together to go through B and C, but we don't know how much is at each, so I'm actually going to pause on that for a second. We can use current to get the rest of the way through this problem. We know the total current is 0.34. That current is going to split, and we already know how much current goes through D. That would be 0.242 amps, which means if you subtract that from the total current, you find out how much goes through this middle branch. So if I subtract 0.34 minus 0.242, you get 0.098 amps, and that has to go through B and C because they're in series. 0.098, 0.098 use Ohm's law. 30 times that gives you 2.94 volts. 20 times 0.098 gives you 1.96 volts. And if you add those together, you get approximately 4.84 volts, which is what we need. And again, to get power, just do I times V for each column. I'm running out of time limit on my free video to upload to YouTube. I only have 4.5 minutes, so I'm going to jump right to number 4 from my channel problems 2. You can do 1, 2, and 4. So let's get the given information down. So I've got my resistances, my battery voltage. I'm going to try and find the total resistance. So if I combine A and B, which are parallel, using parallel rules, I get a resistance of 13.33 ohms. Do the same thing with C and D using the parallel rules, and get 15 ohms. Now the two resistors that we just found are technically in series with each other, so that we can just add them together to get 28.33 ohms. Next I can use Ohm's law times I equals V, so 9 divided by 28.33 gives you 0.318 amps total current. Okay. Now since we don't have any resistors that are just in series with the battery, I can't write that 0.318 amps of current for any of the resistors. But if you look at what we just did with A and B, we combine them together to make one resistor with a resistance of 13.33 ohms. Same thing with C and D. We combine them together to make one resistor with a resistance of 15 ohms. Okay, so let's imagine that our circuit is now 9-volt battery, one resistor here, one resistor here. This one's 13.33 ohms. This one down here is 15 ohms. The problem gets a little bit simpler because we already know the total amount of current is 0.318 amps. So if I look at my top resistor, if it has 0.318 amps going through it, total, that would be spread between branches A and B, I can do current times resistance to get the total voltage. 13.33 times 0.318 is 4.24 volts. Similarly down at the bottom, again the current is still 0.318 amps, so if I multiply that by 15, you get 4.77 volts total between C and D. And since C and D are parallel, they have to have the same voltage as each other, so they're both 4.77 volts. Same thing with A and B. They're parallel to each other, they have to have the same voltage, so that's both 4.24. Then you can do V divided by R to get all your currents, so 4.24 divided by 40 gives you 0.106. 4.24 divided by 20 gives you 0.212. 4.77 divided by 20 is 0.239. And 4.77 divided by 60 is 0.0795. And finally, you can get your power column by doing I times V. Hope that helped. If not, you can always email me tomorrow and I can either Teams chat with you or email you back and kind of give you some assistance. So, good luck.